Hello guys, and welcome to episode number 51, where we'll be solving 5 more SQL problems, this time from the company Uber right here. So let's get started with problem number 1 right here. For each service we have to calculate the percentage of incomplete orders along with the revenue loss percentage. Sounds like we have 3 columns. Your output should include name of the service, 1 column, percentage of incomplete orders, 2 columns, revenue loss. And incomplete orders, it is a filter. So we have 1 filter and we have to show 3 columns. So let's get started here. Let's do for each service, the for each service part. Let's see here, service name. We're going to select the service and then we group by the service. Now we finished for every service part. Now let's figure out the filter, incomplete orders. Incomplete orders. We have here status of order, which is a varchar. That sounds like could be useful. And here the status of order can be cancelled, completed, no driver found, other. Alright, so we don't actually have incompleted here. I would say since there are so many different types, we could simply assume that an order which is not completed, anything else means it's incompleted. So we're going to use this right here. We're going to check if it's different than completed, then that's what we need. So now that we figured that part out, let's see what we have to output. Name of the percentage of incomplete orders. So in order to find out this percentage, we have to figure out all the incomplete orders, that number, and then divide that number by the total amount of orders. And since these have to be 2 different columns, we have to write them here. So we are going to use a case when the status of order, it is different than completed. Then we want to see the number of orders here. Otherwise, we want to see 0. I'll just expand this a little bit so we can see better. So here we're saying when the status of order is different than completed, then just show me the number of orders, which is an integer right here. Otherwise, show 0. And we have to sum these up to find the number right here. This entire row represents the number of incomplete orders. Now we have to divide this by the total sum of the number of orders. And lastly, we have to multiply by 100. And if we just output this to test out, and let's rename this really quick. It looks absolutely horrible. Let's rename this to order ratio. For every service name, now we have a ratio of completed orders. So here it would say 33.9% are incomplete orders, 20%, 23%. So these represent percentages of incomplete orders. And now the other column has to be revenue loss percentage. And this one is basically the same row, just that instead of the number of orders, we are using the monetary value right here. And we're going to change it to sales ratio or something. And now we have for every service name, we can see the percentage of incomplete orders and the percentage of revenue loss. And that is the final solution, guys. And well, it seems it's not correct. But looking at the results here, it doesn't make sense. Their own solution, their own solution has a wrong value. And our solution, so you see here is 20.31. And we have 20.311. Actually, our solution is correct. All of them have 3 digits. And in here, for some reason, this row, I have no idea why. Their solution has 0.31. Actually, our solution is the correct solution. And as a bonus, guys, we can also write this entire thing here in a different way. We can say the sum, and then instead of using case when, we can just use if status of order not equal with completed, then the value in case it is true and the value in case it is false. Now the rest is the same. We have to divide by the sum multiplied by 100. So right here. And now if I delete this part and keep just this one, we should have the same output. There we go. The same wrong output apparently. So this one here and this one here, does exactly the same thing. Here we're saying if the status is something, then true or false. And here we are basically saying in the case of this is different than completed, then do this, otherwise do 0. So this is shorter, easier to understand. So quick recap, guys. We have for every service, we have to calculate the percentage of incomplete orders and the percentage of monetary value, basically. I don't know why they call it revenue loss. And the way we're doing that is we are checking for orders where they are different than completed, which would result they are incompleted. And if they are, then we are going to use that value. Here is monetary value and here is number of orders. Otherwise, if this filter is false, we are just going to put 0 there. So here we're only going to get values of the monetary value and the number of orders, otherwise 0. And now we want to sum the number of these orders. And lastly, we want to divide, in both cases, we want to divide by total number of orders, right here, total number of orders. And then to round things up here, we want to multiply by 100. Problem number 2. You're given a table of Uber rides, contains mileage, and the purpose for business expenses. You're asked to find business purposes, generate most miles, passengers that use Uber for their business transportation. Business transportation could be a filter. Uber could also be a filter, but everything is from Uber, so this is not a filter. What we actually have to output is top 3 business purpose categories by total mileage. So it sounds like we have to output one single column, which is the business purpose categories. But since we have to show it by this, maybe we have to show this one too. I don't know. Let's check the expected and yes. It's not really clear. Literally, if we read, it says find top 3 purposes. That's it. So this one shouldn't even show up in here. So let's try. First, we have to rank basically every business purpose. And since we want to show up the mileage too, we have to actually group by. So we're going to say for every purpose here, every purpose, group by purpose, show me the miles is a float. So we're going to say sum of miles, total miles. And now we want to rank the rows over order by sum of miles in descending order. And we're going to rename this to R and K. Now we're going to copy everything. We're going to put it in a CTE. We're going to arrange it a little bit. And now we just want to select the purpose and the total miles from the CTE where the R and K is less or equal with 3. And this should be the final solution. My bad, guys. I forgot about our filter here. We have a business transportation specifically. So here you see we have a category. And there's business and could be something else. Yeah, personal. Could be personal or business. And we only care about business. So we're going to say here, let's put it in here where the category equals business. And now this should be, yes, the final answer right here. So quick recap. In the table above right here, we are ranking every purpose. So for every purpose here, we are ranking them based on the total sum of their miles in descending order. And we only want those which are in the category called business. And down here, we are only selecting the purpose and the miles where the rank is less or equal than 3, which equals with top 3 right here. Problem number 3, we have to find the total monetary value for completed orders, sounds like a filter, by service type for every month. So per month, per service type, the value for this filter kind of order. We have to output result as a pivot table where column for month and columns for each service type. So if I understand this correctly, we have to have like a column here. This would be the month. And then we need more columns like this. And each of them is a service type. Service 1, service 2, service 3, and service 4, and so on. That sounds like a lot of manual labor. Let's check service type, service name. Let's see how many we have. 6 distinct service names. Wow, that is a lot. So we have to show a category for every single one of these. And there's actually no simple way of doing this. Oh, it is simple, just that it's a lot of work. Now let's start with, before we select anything, we have a filter here where for completed orders. So status of order equals, we used this data set before, so we know it's completed, right? We have our filter, and now we want to do for every month. So we're gonna say for every month, and we have here order date, and we're simply going to use the month function on this. We're gonna call this month. Let's just do it like this, and now we're gonna group by this. Oops. Group by. So far, what we are saying is group by every month where the orders are completed. And now we want to show something. And we want to show based on the status name, the service name for each single service. If we look at expected output here, every single service represents a new column. And we have to manually add these, all of them. And in here, the value represents the monetary value, basically. This here. This is what we want to show. I'm going to actually use this from here, the columns. We simply have to check for every single one of them. We're going to say some case when the service name equals with UberBox. And I believe actually it is with capital letters. Yes, great. It is with capital letters. So when the service name is with capital letters, then we want to show the monetary value. And that's it. We don't care about any other value. We're going to rename this as, just going to simply copy this and paste it here. So in this case, if we go like this, now we have the first column. And if we check the output, well, here they're not organized. But if we look at this number, starts with 75, 175, right? 175. Then we have 274. Second month, 74 something. 389, 443. Okay, so they're the same. There's only 4 months in the data set, and these are the values for this particular, what is this, a service. And now we have to do this for every single row, and this is very boring, so I will just complete this and then skip so you guys don't actually watch me write this. And there we go, guys. This is the final result, and this, I hope it actually works. And there we go, it actually works. Whew, very nice. I made it look kind of, you see, it just kind of triggers me whenever I see so much repetitiveness in here. So this is the final solution, guys, right here. We are creating new columns for every single category. Now this is not automated, so if someone else adds a new category or deletes one, this code is not going to work. So this is not a great solution, but it is a workable solution. So quick recap, what we are doing here, we are saying for every month where the status of the order is completed, we want to sum the monetary value right here. The monetary value, we want to sum it. Sum the monetary value, and then we want to filter for every single one of them. Problem number 4. Write a query to calculate longest period in days. Calculate longest period in days. Company has gone without hiring. So condition is without hiring. Calculate longest period without firing anyone. Limit yourself to dates inside the table. Last hiring termination should be latest. Don't go into the future. I don't understand why they even mention this. So we have to basically calculate 2 things, 2 values, 2 numbers. That's the final result is 2 numbers. And here the filter is without hiring. And here the filter is without firing. So the difference in days, let's check out the data here. Name of the person, their ID, their hire date. Now we only really care about these 2 right here. We only care about these 2. To figure out the first one, the number of days gone without hiring anyone. Basically, we have to find the difference between the dates, right? The difference between the dates, each set of dates, and then we want to output the maximum number right here, and the same for the termination. So let's get started here. Now, since we want to calculate the difference between days, then we have to use the dateDiff function right here. And we simply want to put the dates. Now, the first date is going to be the current, and the next date has to be the previous date. And for this, we are going to use the lag function. And this one basically is going to find, let's say, let me show you right here. So it's looking at the table like this. It's going to say this would be the hire date. And then the lag on this hire date would be the previous one. But since there's no previous one, because it's the first one, it's going to be just no. But from the other row, it's going to take this one. It's going to be the hire date here. And then the lag one, it will be the previous row, this value right here. So let's just write that. Actually, let's not do the date diff so that you can actually understand what's going on. We're simply going to put the dates side by side. We're going to say lag hire date Now we're going to do this by ordering them based on the hire date ascending. And we're going to call this previous date. And let's just run this. And there you go. You can see here the first date obviously doesn't have a previous date. But this one, the previous date is this one. And now here, the 15th, the previous one is the 3rd, right? So they would be something like this. If I could make an arrow, they would be like this. Why are we doing this? Because we want to get on the same row 2 different values. And then we simply want to say the difference between these 2 values. And we will have the number of days between these 2 dates. So that's what we are trying to do. So I'm going to keep these here. And I'm going to add another column where we actually do this one. So we're going to say different date def. We're going to say hire date. And then, okay, so now we'll take the previous date right here. And now we do the difference between them. And we're going to name this difference. And if we check it out, there we go. So this is what we are actually doing. Between this would be the present, the current day, and this is the previous one. And there's no difference between them because it's the same. But right here, you can see this one in the previous date. So this one right here is this one, and this would be this, and so on, right? And you can see the differences between them. Now, all we want to do is find the maximum value in here, because that would be the maximum period of time between hiring employees. So now we will remove the first and second column. We're only going to keep the 3rd one, and then we're going to do a max on it. I'm going to remove these 2, and on this date difference, we're just going to say, show me the maximum value. But we actually cannot do that right here because this is a list. So we're going to have to transform this entire thing into a CTE, into a temporary table. And then we'll select the maximum right now, the maximum difference from our CTE. And there should be the final number right here. We're going to call this one the hire date. And this we're going to call it the max hire date. And we have to copy this too. So there we go. So now we found this part of the puzzle. We have to find the other one, which is simply the same thing, but with termination date. But we're going to simply take this entire column right here and paste it again. And now we just replace the hire date with termination date. We're going to call this termination date difference actually to make a difference. And here, hire date difference. And now we are going to do a max. Again, a max on the termination date difference, and we're going to call it max termination date. And this should be the final solution. If I could finish this. Termination. There we go. There you go, guys. That's the final answer. I know it's a little bit scuffed, but let's go through a quick recap here. In this table right here, we want to create 2 columns, right? 2 columns. One with the difference between hire dates, and one with the difference between termination dates. We have here hire dates and termination dates. And to see the difference, we have to take the current row and then the previous row. So here in red right here, this is the previous row. In the previous row, we have to use the lag function on what field, and we want the same field. And before you choose that one, they have to be ordered, and we also order by termination date in ascending order because we didn't mention any parameter here. And lastly, down here, we want to simply select the maximum value from these tables, the maximum value here and the maximum value here. And down here, we can see those results. And problem number 5, guys, the last one for today, find the average effectiveness of each advertising channel in this period right here. The effectiveness is calculated as the ratio of total money spent to total customers acquired. So the money spent, we have to find that one out and then divide by customers acquired. We need 2 numbers, and then we have to output the channel along with the average effectiveness. And lastly, we have to sort by average effectiveness ascending order. So let's get started here. First of all, let's do the group by for every advertising channel. Select advertising channel, group by advertising channel. Now, what do we have to show? So actually, let's do the filter because that's an easy part. Where the year between 2017 and 2018. And now we have to find this one, the total money spent and customers acquired. Money spent. that's an integer, so we have to simply sum it up, and then we want to divide this by the count. Actually, it's still a sum because we have it here separate. Sum of money spent divided by sum of customers acquired, and this would be, let's call it the ratio. And lastly, we want to order by our ratio in ascending order, and this should be the final solution right here, if it would work. Must be logged in. Are you For some reason it logged me off while I was coding. This doesn't make any sense. So here's the final solution, and everything seems to be fine. Here are the advertising channels, and this is the ratio of money spent to customers, 827%. So quick recap here: for every advertising channel where the year is 2017 or 2018, we want to calculate right here the sum of money spent divided by sum of customers acquired, and that would be our ratio right here. And lastly, we want to simply order by this ratio in ascending order because we didn't specify a parameter. So that was it for today, guys. Thank you for watching, and if you enjoyed these types of problems, I highly encourage you to join the StrataScratch community. Consider using the affiliate link in the description below. Thank you for watching, and I'll see you in the next one.